At the beginning of each lab, it is crucial that your lab book is set up neatly. Remember to add titles, page numbers, and dates. It is also important to record the weather, serial number of any equipment you use, and the task of each team member. In this lab, you will perform a traverse around the ADL. Begin by drawing a map of the traverse and label each station point. Don't forget to record all data throughout the duration of the lab. When you go to set up the instrument over your station point, it is wise to put effort into ensuring the best positioning of the tripod, as it is the base for all of your measurements. First, unpack the tripod, as shown previously. If you are working on a hard surface like asphalt, as in this lab, you will not be able to push the feet into the ground to get stability. You will need to spread the legs enough to create a stable platform. Extend and lock the legs to give you a comfortable working height, keeping in mind you will need to be able to see through the eyepiece of the instrument. Place the tripod legs where they will not be in the way. You will need to work around the tripod, and if you bump into the legs, the instrument would go out of level and you would have to start all over again. So ensure the tripod legs are not in the way of you standing as you look through the eyepiece for both the forward and the back sights. You will also want to ensure that the legs will not interfere with or block any tape measurements you also need to do. Set the tripod over the station point by looking down through the hole in the platform. Accuracy and positioning here will ease the precision alignment later. In order to make the precision leveling of the instrument easier, it is wise to start with the tripod base as level as possible. Have one of the teams stand off at a distance and tell you how much to raise or lower each leg to get that level. Check that the tripod is still centered after the leveling process. Readjust it if necessary. You are now ready to mount the instrument. Begin by bolting the instrument onto the tripod. Press the red on and off button on the right side to start the instrument. Next press Function, or FNC. Finally press F1. Notice where the red laser light is in relation to the station point. Adjust any or all of the 3 foot screws to center the light on the station point. Adjust any or all of the tripod leg lengths to center the lower fisheye bubble. Perform the electronic leveling by using the foot screws of the tri-brack. The screen will then tell you what foot screws to adjust and which direction to turn them. Move them slowly and deliberately, as they are sensitive and it is easy to overshoot the level. When all 3 check marks appear, check if the red light has moved off the station point. It likely has. If it has, loosen the bolt and slide the instrument over the station. Be careful not to let the instrument rotate on its tripod. You are trying to maintain the level, so move it in a straight line. Retighten the bolt and repeat the previous step until the instrument is both level and aligned. When the instrument is both level and aligned, press F4 or OK. The menu-driven programming of the instrument is very linear and literal. Each step must be followed in this order in order to complete the setup. Press the menu button. Press F1 for Program. Press F1 again to select Surveying. Press F1 to set the job. Press F1 for New Job. Enter the job name as G, whatever group number you are designated. To enter an alphabetic character, type any letter and then press F4 to change from alphabetic to numeric. Press F4 again to change back to numeric mode. To erase a character, highlight with the directional pad and press down. Once the job name is defined, press the red Enter key. Now press F4 for OK. Press F2 to set the station. Enter the station number as S1. The station is the location of the point underneath the instrument. press Enter. Press F3 or ENH to set east, north, and height coordinates for station S1. If you knew what your latitude, longitude, and height above sea level, this is where you would enter it. But for the purposes of this lab, we will use the following data. The instrument will not allow you to skip this step. Key in 10,000 for east, 5,000 for north, and 100 for height. After each entry, press the Enter key. Now press F4 for OK. Now you must measure the height of the instrument. Determine the height of the instrument by measuring the vertical distance between the ground, point S1, to the point on the side of the instrument where an indentation exists. Be sure the tape and subsequent vertical measurement is vertical. If the ground below the instrument is not flat, i.e. sloped, take the measurement from both sides of the instrument and calculate the average. Enter the calculated height. Press Enter, and then press F4 to save the data. Back in the surveying menu, press F3 to set the orientation.